and how they actually fly. This worker is connecting a hose to the bottom of an airplane. He's not refueling it. Most modern commercial jets use a vacuum toilet system, where all waste is sucked by strong air pressure into a sealed holding tank located underneath the fuselage. Nothing gets dumped mid-flight. It's only after the plane lands that ground crew open the hatch like this and pump the waste from the holding tank into a sewage truck. You might be wondering, what about those stories of blue ice falling from the sky? Isn't that airplane toilet waste? Actually, no. Airline lavatories are completely sealed. But if the blue disinfectant fluid from the toilet system leaks slightly, it can freeze at high altitude and fall as chunks of blue ice. So if you're lucky enough to spot blue ice, never try to lick it. Why do airplane cabin doors need flight attendants to open and close them manually? Can't they just use automatic doors like the subway? Actually, it's not that the technology doesn't exist. The real issue is safety and reliability. If an aircraft were fitted with a fully automatic door system, then in a case of emergency landing or power system failure, the automatic mechanism might break down. If the door won't open, the consequences can be very serious. But with a manual door, even if the power is out, it can still be operated by people to close or open it. Also, airplane doors have to maintain air pressure sealing. The cabin is pressurized during flight, so the door must form a tight, secure fit with the fuselage to keep the pressure difference inside versus outside the plane safe and manageable. If everything was fully automated, there might be a risk of an imperfect seal. At the same time, manual operation helps prevent accidental button pushes that could trigger the door to open unintentionally. So, would you like airplane cabin doors to be upgraded to fully automatic? Can you believe it? A mechanic actually used tape to fix a plane. Aren't they afraid it'll fall apart mid-air? Don't worry, that's not regular tape. It's a special aviation repair tape called speed tape. This stuff is designed to handle extreme conditions, from freezing temperatures at 35,000 feet to air speeds over 500 miles per hour. Even in those harsh conditions, it sticks firmly to the surface without peeling off in the wind. Speed tape is made of aluminum foil laminate and high-strength resin adhesive, which lets it seal small cracks, loose panels, or worn paint areas while preventing corrosion from moisture and salt in the air. But don't get it wrong. It's only for non-structural damage. You can't use it to fix a broken wing or a dented fuselage. Airlines apply it only as a temporary fix, just to keep the aircraft safe enough to fly back to a maintenance base for proper repair. So yeah, it's basically a band-aid for airplanes. But tell me, would you still get on a plane that's covered in tape? This is a mechanical gyroscope. During World War II, tens of thousands of planes relied on it to find their way home. So how does it work? Inside is a small metal wheel that spins at high speed. Once it's running, shake it, twist it, flip it, and it still refuses to tilt. For pilot, axis was everything. It told them how much the plane was turning and how fast. And when they flew into thick clouds with no horizon or landmarks in sight, this little device became their eyes. Without it, they might have ended up circling aimlessly over the Pacific. Of course, not all gyros are the same. Fighter jets needed compact, quick response systems for precision and agility. Submarines, on the other hand, used massive, heavy versions. Today, things have gotten even more advanced. The old spinning gyros have been replaced by electronic, fiber optic, and laser gyroscopes. Different technology, same principle. Using a gyroscope's natural resistance to change as the ultimate guide to direction. Did you know? Most airplanes actually come with a backup physical key. It's usually hidden behind an inspection panel near the nose of the plane. Open the panel, and you'll find the key. Slip it into the lock just under the cabin door, give it a turn, pull the handle, and the door opens. This airplane spare key is normally kept by the crew or ground staff. But here's the thing. In most cases, it's almost never used. Modern airliners rely on electronic locks or coded systems. Punch in the right code, and the door unlocks automatically. On newer Boeing and Airbus jets, even the cockpit doors have electronic emergency keypads. If there's an emergency, flight attendants can try entering a special override code to get in. Plus, commercial planes fly almost every day, so the cabin is rarely ever left unattended. The only time that physical key really comes into play is when a plane has been parked for several days and needs to be unlocked before its next flight. So what do you think? Do airplanes still need an old-fashioned key? Can you believe it? Just replacing the tires on a Boeing 747 can cost hundreds of thousands of dollars. A 747 has 18 massive tires, and each one needs to be swapped out after about 150 flights. During inspection, mechanics insert a coin into the tread grooves to measure the depth. If the grooves are too shallow, it's time for a new tire. Before installation, the new tire gets inflated with nitrogen instead of regular air. Why? Because nitrogen doesn't expand and contract as much under extreme temperature changes, making it safer and more stable at high altitudes. To change them, a huge pneumatic hydraulic jack lifts the airplane off the ground. Each tire weighs over 300 pounds, way too heavy to move by hand, so mechanics use special lift carts to haul them into position. The mechanic then tightens the locking nut and reinstalls the hub cover. Once the jack is lowered, the plane is ready to roll again. Here's the crazy part. Each tire costs around $20,000. So what do you think? For that kind of price tag, do you think it's worth it? Do you know what the steering wheel of an airplane looks like? Actually, airplanes don't have steering wheels at all. The real control tool is called the control stick. It looks a bit like a gaming joystick. Push it left or right, and the plane tilts in that direction. Push it forward to lower the nose and descend. Pull it back to lift the nose and climb. But here's the thing. The control stick doesn't directly move the wings. Modern planes use something called a fly-by-wire system, which means the pilot's hand movements send electronic signals to adjust the ailerons, elevators, and rudder. In other words, they're just giving the computer precise commands to execute. You might also notice that many aircraft have two control sticks or yokes. That's not redundancy. It's a dual control system, allowing both pilot to share control in real time. But only one side can be the master control at a time, to prevent accidental inputs from clashing. So, if someone handed you the controls of a Boeing 737 right now, would you dare to take off? Why do so many airliners have a little bump under the tail? On takeoff, it sticks out. After landing, it quietly tucks away again. It's called a tail skid, and its job is simple. Protect the aircraft from tail strikes. When a plane takes off, the nose lifts first. When it lands, the tail comes down first. That's because modern airliners all use a tricycle landing gear layout. One nose wheel and two main wheels. If the pilot pulls the nose up just a little too much, the tail can scrape the runway. So the tail skid works like a rear bumper for airplanes. If the angle gets too high, the skid touches the ground first and prevents the metal fuselage from grinding open. Why does it matter? Because it's not just a scrape. A bad tail strike can tear open the plane's skin. Some planes don't use a skid plate. They use a small tail wheel instead. Examples: certain Airbus A340s and Boeing 767s. So next time you board a plane and spot that little bump under the tail, just remember, that's the aircraft's butt guard. This pilot opened the plane's window while flying at high altitude, but what's weird is that it didn't cause any danger. In a similar case, another pilot tried the same thing. Aside from extremely strong wind, no other danger occurred. Actually, this happened at altitudes below about 33,000 feet. At that height, the outside air pressure and temperature can still be within a tolerable range for humans. But above roughly 33,000 feet, if a window is opened, the high pressure difference could immediately pull a pilot out through the window. In fact, the small windows in the cockpit are called cockpit side sliding windows, and they are intended to help regulate cabin pressure balance and airflow. You'll often see these windows open during takeoff or landing, but once the plane climbs to a certain altitude, the windows must be quickly closed. Usually, opening such windows in flight is more of a daredevil move by individual pilots. If an airline finds out, the pilot can risk fines or even being fired. So, do you think such windows should even exist? Ever wondered what's hidden inside a plane's nose? Inside, it actually hides the plane's eyes, the onboard radar. It works by sending out invisible radio waves. When those waves hit clouds or raindrops, they bounce back. The radar then analyzes how strong and how fast those signals return, helping the system figure out whether the skies ahead are safe to fly through. If the return signal is strong, it means the clouds are dense and full of moisture, a clear sign of heavy rain, hail, or thunderstorms. That gives pilots time to change course and steer clear of dangerous turbulence. But radar isn't perfect. It can see rain and clouds, yet it can't detect clear air turbulence. There's another catch. If the radar transmits too much power, it can interfere with other onboard electronics. That's why pilots rely not only on radar, but also on satellite weather systems and air traffic control guidance. So if one day, artificial intelligence could predict invisible turbulence more accurately than humans, would you trust your flight safety entirely to AI? Can you believe it? Replacing an airplane engine blade can cost $750,000. So why do they need to replace it? Those blades face extreme conditions, thousands of degrees Fahrenheit, and tens of tons of thrust. If they get worn out or deformed, it could easily cause a major aviation accident. That's why airlines have to replace them regularly. So how do they replace it? First, mechanics open up the engine casing and remove hundreds of turbine blades one by one. To avoid mixing them up, they usually mark each blade with a number. After pulling out the faulty blade, a brand new one goes in, and each piece has to be perfectly balanced. Because if even one blade is off in weight, the engine will in flight or even blow apart. And here's the crazy part. Each little blade weighs less than a pound, but costs about $8,000, with labor about $10,000. Put it all together, and the full replacement cost hits $750,000. So, do you think it's overpriced, or worth it for safety? Leave this? Some airplanes actually have a plate mounted behind their land gear, but don't get it wrong, not for landing on snow. That metal piece is called an FOD deflector. Back in the early days, many planes had to build with gravel. When the wheels spun up, they could kick small stones right into the engines. Engineer two clever defenses. First, that metal shield behind the landing gear blocks flying debris so the rocks don't hings or engines. Then, take a look at that metal rod still in front of. That's called a vortex dissipator. When it runs on the ground, it creates a strong suction vortex under the intake, pulling in dust and pebbles. The dissipator shoots out high pressure to break up engines safe from getting eaten by debris. Even today, many old aircraft flying in Alaska still rely on these two devices to survive. Do you think it's still necessary today? If a pilot ever skips this step before takeoff, the plane could literally crash. That small bottle of liquid drained from under the wing, it's actually jet fuel. Before every flight, ground crews use a special tool called a fuel sampler to drain a small amount of fuel from a valve at the very bottom of the tank. That spot is the lowest point in the fuel system, where any water or debris naturally settles. They'll then hold the sample up to the light to check its color and clarity. If it looks cloudy or has tiny bubbles, that usually means water or contaminants have mixed in. So why so cautious? Because even a single drop of water can freeze at 30,000 feet, clogging the fuel lines and cutting off fuel to the engines. And if dust or metal particles get in, they can scratch the fuel pump blades and cause the engines to lose power. In fact, this isn't just a theoretical risk. Back in 2008, a British Airways Boeing 777 lost power in both engines while approaching Heathrow Airport. Investigators later found that ice crystals in the fuel had blocked the fuel flow, causing both engines to fail. This is one of the highest paid jobs you'll find at an airport. A single job can earn tens of thousands of dollars. They're called aircraft structural repair technicians. But don't let the paycheck fool you. The pressure can be brutal. Right now, you're watching them basically give a plane a new skeleton. These techs are sliding a massive metal frame into the fuselage. It weighs a few hundred pounds, and if they misalign it even slightly, it's scrap. Even being off by 0 point, the aircraft fail in flight. This kind of work is called heavy structural repair, usually done after major inspection, serious damage. The plane stays grounded for days, sometimes weeks, until it's done. And the precision doesn't stop there. They run. There are zero hidden cracks or gaps. And the working conditions? Brutal. Crawling inside tiny airframe spaces, bent over, jammed above your head, repeating the same muscle motion thousands of times a day. That's why the job pays so much. Why is this thing with a remote control? Don't get it wrong. This isn't a toy. It's a next-gen remote-controlled aircraft tug. This little machine can push a commercial over 80,000 pounds away from the gate, all on battery power. How? Inside, it uses hydraulic, then an electric motor and differential system, steer and power with precision. Old-school tug-located hooks and bars to connect. This one? It just bites onto the tire and go. And the best part fully electric. No diesel fumes, no engine noise, and it keeps planes from running their own